Hello and welcome to the third and final lesson on statistical distributions for Chapter 6 of the Stats bit of the Year 12 A-level course. So far we've had a look at how we can represent distributions statistically, including probability mass functions and how to illustrate them in tables. Last lesson we had a look at what was known as the binomial distribution, where we introduced how to use the Classwiz to perform calculations. This subchapter is going to be very much in the same vein. We're going to have a look at how to use the Classwiz to do even more tricky calculations, and the objective of today is that by the end of watching this video, you'll be an expert at performing calculations on the binomial distribution quickly, efficiently, and confidently. So let's get started now by having a look at some warm-up questions to get you in the mood. So almost as ever, there's 4 to have a go at. Press pause some point around now to have a go at these on your own independently. Only press play when you're ready to be guided through the solutions to them. Righty-ho, so let's have a look now at warm-up question 1. We have unit vectors I and j which are perpendicular to each other. We're asked here to find the magnitude of the vector minus 15i plus 22j, leaving your answer in exact form. So we need to remember to find the magnitude of a vector is essentially using Pythagoras. Okay, so the magnitude of a vector we write with these 2 vertical lines in between. So the magnitude of a vector 15i plus 22j, like this, is just going to be the square root of this coefficient of the I squared plus the coefficient of the j squared. All of that square rooted. Okay, so if you want a very quick recap of what the magnitude means, it means the length of the resultant direction of the combination of the 2 vectors or more. So for example, minus 15i, I goes along the x-axis this way, and j is in the direction of the y-axis, so j would be going up. And so the overall direction of these 2 combined, the resultant, would be this red line here. And so to find the magnitude, all we're doing really is finding out the length of this red line. Okay, just a quick recap of the vectors. So this bit would be the minus 15i. This represents the 22j, not done to scale. And the yellow bit, the magnitude is just the length of the resulting line, the resultant vector. So it's like Pythagoras really, that side squared plus this side squared. So if we work this out on a calculator, what we're going to get, minus 15 squared, that's just the same as 15 squared, and the squared numbers are always positive, plus 22 squared, that gives us root 709. So in exact form, I'm going to leave this as root 709. Let's now have a look at warm-up question 2. Question 2, it says, using your answer to question 1, write a unit vector that is parallel to the vector minus 15i plus 22j. Well, a unit vector parallel to this one is going to be minus 15i plus 22j divided by the magnitude of that vector itself. So we divide it by the magnitude of minus 15i plus 22j. But of course in question 1 we worked out the magnitude. The magnitude was root 709. And so this is just 1 over root 709 multiplied by minus 15i plus 22j. And that's all there is for that one. So let's have a look at question 3. We need to be really careful in question 3. Okay, it's a mechanics question. So mechanics, almost always, the key is to do a carefully constructed diagram. So in taking off, we're told an aircraft moves along a straight runway A, B. So first of all, I'm going to draw the runway in. Okay, so the runway goes from A to B. So I'm going to label the start of the runway at A and the end B. Even this bit, as simple as this seems, that is really important to get labelled right. I'll explain why now. So anyway, we're told it starts from A with an initial speed of 2 meters per second. So I'm just going to draw a blob here, which will represent the aircraft. You don't need to be an artist for maths. Obviously, if you are, that's great. So it's going to start here with initial speed 2 meters per second minus 1. So it's going forward at 2 ms minus 1. We're also told it moves with constant acceleration. And so the acceleration, we can say, is going this way. Double-headed arrow for acceleration. I'm just going to label this A. Now, in terms of what I said earlier about labelling A and B was simple but crucial, it's because here it says it moves with constant acceleration, and 20 seconds later, it leaves the runway at C. So what I've seen students do before is go A, B, and then label C further on. But just think about what you'd be doing in that case. A, B is the runway. Okay, if you have C outside of a runway, if a plane is taking off outside of a runway, if it runs off the runway and goes onto a grass verge, that's not going to end well. So as tempting as it might be to do A, B, then C after, you need to realise that actually C is still on the runway. So I'm just going to label C arbitrarily, somewhere along the runway itself. So A is going to be here to start with. Later, at C, it's going to go there. Then obviously at C, it says it leaves the runway. So at C, it's going to be finally taking off. So what other information are we told? So notice here, I'm not even answering the question. I'm just trying to make sure all of the information is labelled on the diagram. We're told that AB has length 1.2 kilometres. Okay, 1.2 kilometres. The SI units for distance or displacement are metres. So we need to multiply this by 1,000 to obtain 1,200 metres. And that's the length of the runway from A to B. It's not the length from A to C, it's the whole length of the runway from A to B. So now, I think I've labelled in pretty much everything I can. One thing I could say here as well is that at C, it's got a speed of 74 meters per second, just as it is about to take off. Importantly as well, very crucial, the acceleration is constant. So for part A, because it's constant acceleration, little note to yourself this implies we can use the SUVAT formulae for constant acceleration. So what I intend to do here is just label SUVAT and fill in what we know. So we want the acceleration of the aircraft. So I don't know anything about what happens at B, so I'm just looking at between A and C here. So for displacement between A and C, I don't know, and for part A, I don't need to know it. So the displacement, which is given by S, I'm just going to put a cross for it because I don't need to know it at all. U stands for initial velocity. We're told here that the initial speed is 2 meters per second. So our U is 2. V stands for final velocity, or final speed, if the direction is obvious. So here, we've got 74 meters per second, so we can label this in because we know that. We want to find the acceleration, so I'm going to put a question mark for acceleration, just to denote that I do want to know that. That is literally the question. And T stands for time, so it says that in between A and C, in between A and C, it's 20 seconds later it leaves at C. So it starts at A, 20 seconds later it's at C. And so the time frame we're talking about between A and C is 20 seconds. So this SUVAT is just from A to C. So we want to work out A. and we need a SUVAT formula which doesn't involve S. So what we can do here, I'm hoping you'd come to this conclusion yourself, have a think. We'd have to use V equals U plus AT. So in other words, if we rearrange this, A is V minus U over T, which is 74 minus 2 over 20. And if we now get the Classwiz and work this one out, 74 minus 2 all over 20, that gives us 3.6. So the acceleration is 3.6 meters per second squared. So I can put this in for part A. Now part B, it says the distance BC. So I'm just going to give myself a little more space here. Just going to section this off. Distance from B to C. So between C and B, we're not told any information. After C, the aircraft has left the runway, so we can't really know anything for definite between C and B. So what we're going to need to do is work out the distance from A to C and then subtract that distance from AB. So for part B, again we can apply the SUVAT formulae. So I mean to say from A to C. So again, this is just for A to C. If we work out the distance from A to C, we can therefore work out the distance from C to B. So let's try and work out what the displacement is, the distance from A to C. Again, we knew U was 2, V is 74. We've just worked out the acceleration from part A, it was 3.6. And the time we know is 20. So a formula for S, which involves any combination of U, V, A and T, I'm going to suggest we might want to use S equals UT plus half AT squared. So that's going to be 2 times 20 plus a half multiplied by 3.6 multiplied by 20 squared. So if we just get the trusted Classwiz to do the hard work for us, so we've got 2 times 20 plus 1/2 multiplied by 3.6 multiplied by 20 squared. And that gives us 760 meters. That's not the final answer. Okay, that's just for A to C. So for A to C, the distance is 760 meters. And so just for the sake of clarity, we may as well label this in. Okay, so this here is 760 meters. But now, like I say, we can now work out the distance from A to B. So therefore, using this diagram, hopefully you'll spot quite obviously that the distance, so BC, therefore BC must be the whole of A to B, which is 1200, minus the 760 we just worked out. Okay, what will be left will just be this distance here. And that's exactly what we're wanting to find. So BC is 1200 minus the 760. And if you check that on your calculator, you should get 440 meters. Finally, for the warm-up, let's have a look at question number 4. Here we're told that the product of 2 consecutive positive integers is added to the larger of the 2 integers. Prove that the result is always a square number. So let's have some representatives for these integers. So let integers be given by n. So n is going to be the smaller one, and n plus 1 is going to be the larger one. So consecutive means next to. N plus 1 just means the one integer which is just next to. One higher than n is n plus 1. So what we're going to have there, the product of the two consecutive integers is going to be n multiplied by n plus 1. Now it says that's added to the larger of the two integers. The larger one is going to be n plus 1. So now we can expand this. So n multiplied by n plus 1, expand this out, we get n squared plus n. Of course here we have another n plus 1. Simplify, we get n squared plus 2n plus 1. And what you need to notice here is this will factorise into a perfect square. Think about any quadratic. We need two numbers that multiply to 1 and add up to 2. Those numbers are going to be 1 and another 1. In other words, that's n plus 1 squared. So therefore, the result is always a square number. And we've done the proof. So now we can get on to the main portion of the lesson, which is talking a bit more about this binomial distribution. So let's have a look at what's in store for today. What I'm going to mention here is called the cumulative binomial distribution. So a cumulative probability function for a random variable x tells you the sum of all individual probabilities up to and including the given value of x in the calculation for the probability of the variable being less than or equal to little x. So for the binomial distribution x following b and p, there are tables in the formula book giving p, brackets, big X less than or equal to little x for various values of n and p. So there is an extract from the tables below. Okay, so I'll show you an extract from the tables in a moment. If you're wondering what the actual book looks like, I'll show you in a moment. So this is the extract from the tables, and all this is included, by the way, in the formula booklet you'll be given for your exams. This is what it looks like. This is just an extract. So this is for the probability going up in increments of 0.05. Here we've got a total number of trials is 5, and the probability of x taking on the value of 0 is given, then all the way up to 1, 2, 3, 4. If you notice here, these values tend towards 1, because obviously the chance of the variable taking a value of up to and including 5 is going to be a certainty, because up to and including 5, because this is cumulative, it's going to keep adding up until we get closer to 1. Okay, so if we did go up to 5, all of these values would be 1 exactly. The start of the next one for n equals 6 would be given. This would actually go down here, which I've cut off in this extract. This would go down further on the page in the booklet. Okay, so when questions are set in context, there are different forms of words that can be used to ask for probabilities. The correct interpretation of these phrases is absolutely critical, and this is the main stumbling block for people. Okay, especially when you're dealing with cumulative probabilities, people can get thrown off if they're not careful by how the question's worded. And so I'm just going to show you a little table giving some examples. So if you had a phrase or a phrase similar to this in an exam, greater than 13, numerically, what would that mean? Well, greater than 13 just means we want our variable to be more than 13. However, with calculations, either using the Classwiz or using these probability tables I've just shown you previously, the calculations are based off the symbol less than or equal to. So we always need to do the calculations based on this symbol here. So we need to switch this from thinking of it, instead of x greater than 13, we need to reframe that as thinking of it, that's everything apart from the chance of x being 13 or less. If we subtract the probabilities of x being 13 or less, like we are here, the only probabilities that would be left would be when x is 13 or more. So we need to switch it into this symbol here. If we don't switch it into the form where this symbol's included, we're going to be really stuck. I'll give you another example now. No more than 7. That would mean x is up to and including 7. Here, we've already got the symbol we need. Okay, so we can just work out the probability of that. What if you had at least 9? Well, that would mean x is greater than 9 or could be equal to 9. So again, we need to switch it into one of these symbols. This symbol here is facing the other way. So if x is equal or greater than 9, that's the same as the probability of 1 minus the chance that x is 8 or less. Okay, 9 or higher means 1 take the probability of being 8 or less. So there can never be any overlap here, okay, between this one and that one. Here there's no overlap because of the difference in the symbols. So there must be absolutely no overlap with the values. Fewer than 10. This one just means x less than 10. Again, this symbol isn't in terms of this symbol, so we'd have to rephrase that. X being less than 10, we'd have to have it where x is 9 or less. That means the same thing, but think of it in this way, it's at least in terms of the correct symbol. Finally, if you had something like at most 8, that means x has to be equal to 8 at most, or less than 8. Again, because it's in the form of this symbol, we're good to go, and we can just work out the probability of that. So, returning to what I mentioned earlier about the tables you're given in the exam. The cumulative binomial distribution probability tables are on page 204 and 208 in your Stats and Mechanics Year 1 AS book, the Edexcel ones. Okay, so they're the main course books that are included for you in the physical book. Alternatively, you could ask your teacher, that might be me, to email you a copy. Also, as well, the tables are always located in the exam formula book you're provided for your final exams. So you're always given formulae. Not all formulae, but they're quite generous in terms of what you get. And included at the back of the formula booklet are the tables for working out cumulative binomial probabilities. So I'm going to show you what these look like. Okay, so there's a finger pointing to it. There's the front of the book. So we're going to open, turn to the back. And I've highlighted here, like we did in the last example, where n is 5, 0.25. And you can see these tables are very expansive indeed. So let's do a worked example using the table method. So we've got a random variable x, which is binomially distributed with x following b 5, 0.25. So if the number of items or number of trials is 5, probability of success, or probability of the variable taking on that a value is 0.25. So first of all, find p x being less than or equal to 2, and part b as well. First of all, let's imagine we've got this formula book in front of us, and we open it up and we find the right bit, and we have this. So let's label on what we need. So we've got here our n is 5, so we're looking at these bits here. N equals 6, don't need that. And 0.25 is our probability. Okay, so we're going to be focusing on these values here. We're looking at this column. So for part A, if you notice what I said before, this one is already in terms of this symbol. So we're good to go. So what's the chance of x being up to and including 2? What's the chance that x is either a 0, a 1, or a 2? But importantly, this value here is with 2, which is here, so we just read across and we're after this probability here. Okay, so we're after that one. So the probability for x is up to and including 2, but no more, is 0.8965. Now for part B, we need to reframe this in terms of this symbol. So the probability of x is greater than 1, that's the same as 1 minus the probability that x is 1 or less. So the probability of x is 1 or less, we can find this in the table as well. So our number here is 1, so we look at the table, find 1, go to the correct column, which I said here is this one. So it's going to be 1 minus 0.6328. Now we just need the calculator to work out what that value is, unless you feel confident and want to work it out yourself. But I'd say at A level, never be too cocksure. Always try to work things out on a calculator, just to make sure you don't make any errors. So 1 minus 0.6328, that's going to give us 0.3672. So that's how we can use the tables to help us. There's also a second method, which is my favoured method. Each teacher is different to the next, each student is different to the next. So it doesn't matter which way you use, but I'm going to now explain how you can do this on a calculator. So the Classwiz can compute cumulative binomial probabilities for you directly without need for any tables at all. So to do this, I'll show you now with mine. Okay, so let's just follow this together. So first of all, we press menu, then option 7. So we do menu. If you see here, option 7 is distribution. So you can either toggle to it by using these keys or just press option 7. We now scroll down until we see not binomial PD. So scroll down, but until we see binomial CD. So we can see this here. So then for that reason, we then press 1 to enter that mode. So press 1. You then have an option of list or variable. I'll mention list at the end of this video, in fact. But for now, we're going to press 2. Then we enter the parameters we need. So let's have a look how this works with an example. Just to let you know as well, X on the calculator, X here stands for the number of successes or the number of times the event happens, up to and including that value of X itself. So for example, with the binomial cumulative distribution, if you had the X was 5, that's going to work out for you the probability that X is 0, 1, or 2, or 3, or 4, or 5 itself. N is the number of trials, and P is the probability of success. So let's try this now with a few worked examples. So we've got this random variable X, which is binomially distributed as such. So number of trials is 20, probability of success is 0.4. Find the probability for X is up to and including 7. So what we do here is we get into our binomial CD mode. I'll recap how to do that for you again. So we press menu, go to option 7, this bell curve thing, which you'll find out about in year 13. Press 7, scroll down, press 1 for binomial CD, then we press 2 for variable. Now we input what we need. So here we're told that n is 20, so toggle down, press 20 for n and equals. P is 0.4, so press 0.4 and then equals. And then we want X to be up to and including 7. This symbol's already the correct symbol, so we can just proceed without any worry. So we type in 7, 20, 0.4, press equals again to actually calculate it. and we get 0.4159. 0.4159. So that's our answer for part A. Probability of x is up to and including 7 equals 0. I forgot what I said already, 4159. Next up, part B. Now this symbol isn't quite right yet, so I need to get it into the right form. So the probability for x is less than 6, because we're talking about whole numbers here, that can be rewritten as a probability of x is equal to 5 or less. So here, if we work this one out, so press AC to go back and it will store N and P, what you had before. So now we can just change the 7 to a 5. Press equals and equals again, and we get here 0.1256. If you check this on the tables, you'd get exactly the same results. I personally find this quicker. Some people prefer the visual way of seeing the tables. It's entirely your choice. Now C is the one where students tend to not like. The probability for x is 15 or higher. If it's 15 or higher, that means it's everything apart from the outcomes where it's from 1 to 14 inclusive. And so that's everything, 1, apart from, minus, the probability for x is 14 or less. So again, it always needs to be this symbol and this symbol facing the same way. So now we can work this one out. So press AC again. We're going to go to x being 14. Press equals and equals again. Here we get 0.9984. So we can't work this out. So press AC, go to menu, go back to normal mode for normal calculations. 1 minus 0.9984 gives us approximately 0.0016 to 4 decimal places. Less than a 1% chance. That might seem unusual to you, but think about it. You've got 20 trials. The chance of it happening once is less than 50%. There's only a 40% chance of it happening. So you'd expect, out of 20 trials, on average, about 40% of 20, you'd expect about 8, maybe 7, 8, 9 or something. So to get 9 would be pretty lucky, to get 10, be very lucky, 11 and 12 very lucky, to get 15 or higher, to get almost all successes out of 20, 75% more successes out of 20, when the chance of just one success is 0.4, that's freakishly unlikely. So that's why this probability is coming out very, very small indeed. Second worked example. I'm going to take you back to the ancient Romans for this one. So we've got a spinner. It's been designed so that the probability it lands on a red is 0.3. Caecilius has 12 spins. We need to find the probability that he obtains no more than 2 reds, and for part B, at least 5 reds. So let's work out part A and B. We'll come to part C in a moment. So for part A, the probability no more than 2 reds. So if you're thinking no more than 2 reds, that means you are allowed 2 as an absolute limit. Okay? I don't know if your mum or dad might say to you about playing computer games or having tablet time, whatever. Okay, but no more than half an hour. You'd probably go up to half an hour, wouldn't you? Yeah? So no more than means that figure itself is allowed. So no more than 2 reds means that we can have x being up to and including 2. X, by the way, for this one, okay, because it's a spinner, it's either going to be landing on a red or not. It's binomial. We're assuming here it's a binomial distribution. So x is going to follow binomial. Number of spins is 12. Probability of success is 0.3. So always a sound idea to get that written in actually before we properly begin. So now we've got this, we can key this into the Classwiz or use the tables if you prefer, and for A we can work out this. Probability that x is no more than 2. So we do, just move this to the side actually. So menu, 7, go to binomial CD now, go to number 2 variable, our mention list, like I said. So here we want 2 or fewer out of n, a total of 12. Probability of success is 0.3. Press equals and equals again. We get here about 0.2528. It's about 26% chance. So, part B, at least 5 reds. At least 5 reds means a probability that x is 5 or more. 5 or more means everything apart from 4 or less. That's 1 minus a probability for x is 4 or less. So now we can work this one out. So press AC to toggle back. Now we can change this x to a 4. And we get here 0.7237 to 4 decimal places. 0.7237. So we just do 1 minus that. So AC, menu 1, press 1 again. So then move it away. So 1 minus 0.7237. That's going to give us 0.2763. So the answers to part A is that one. Answer to part B is that one. So if we just think about part B, because this will help us for part C, because the chance of getting a red is pretty rare, only 30% chance, to get 5 reds out of 12 or more, basically about half of them red or higher, that's only a 28% probability. That's fairly rare. So you'd have to be pretty lucky, okay, to get 5 or more reds, because that's fairly unlikely. 28% isn't unheard of, but it's not particularly likely. So I want you to think about part B being adapted to help us answer part C. So Caecilius has this wonderful idea to use his spinner for a competition in Herculaneum. He wants a probability of winning an amphora as a prize to be less than 0.05. So only the top 5% of lucky people are going to win an amphora. 5% or less, in fact. So each member of the town will have 12 spins, and the number of reds will be recorded. And so, how many reds are needed to win an amphora? So essentially, you need to think about this as, how lucky does someone need to be to get within only 5% or less probability of getting that many reds? Okay, so as we saw here, for B, at least 5 reds was quite rare. That was only about 28%. We need to get this number down until it becomes less than 5%. So I'm going to consider part C as an adaptation of part B. Next, I'm going to mention a different way, a different function on the Classwiz which might help you. So for part C, let's adapt part B. So at least 5 reds, that was only 28% chance. How about at least 6 reds? That would be, using this idea here, probability x is 6 or more, that would be 1 minus probability of x being 5 or less. So let's work out what 5 or less would be. So menu, 7, scroll down, binomial CD, number 2 for variable. Now we want 5 or less out of 12. The probability of success is 0.3. 0.8821. So if we work that one out, we'd get 0.1179. So that's only 12%-ish. That's only about 12% likely that someone would get 6 reds or more. So that's very unlikely, but it's not less than 5%. And so that's not quite there yet. Let's try and narrow for at least 7 reds. Probability of 7 or more. That's the same as 1 minus the probability of 6 or less. So that's going to be 1 minus whatever this comes out to be. So press AC, change the 5 to a 6, leave all the other variables the same. And now, if you see here, we get 0.9614. That gives us 0.0386. And that is less than 0.05. That is less than 5%. And so we're good. And so for part C, how many reds are needed to win an amphora? 7 reds are needed. So what's this other way I keep mentioning? Okay, I'm going to show you now a different mode you could have used. So if I press menu, option 7, go to CD again, binomial CD, but this time type in list. This is particularly good for questions of this type, okay, where you're trying to see at what value, at what number does the probability go beneath a certain point. Okay, so what you can do here, you can type in the outcomes you want to calculate. So here we had 12 spins. Okay, so we could type in, I don't know, the probabilities for the first 10 spins. So 1 equals, 2 equals, all the way down to 10. You could skip some out as well. You don't need to do these sequentially. You could skip a few. For example, I'm going to skip X being 8. I'm going to skip straight to 11 and 12. You don't need to do it in any particular order. If I then press equals again, it now tells you what you want the total number of trials to be and the probability of success to be. So I'm going to leave it like we have for this question. I'll now make the screen a bit bigger so you can see clearly what's going on. Okay, so now if I press equals here, it lists the cumulative probabilities for us, and so now we can interpret this in context. So what's the probability that someone gets 0 or 1 reds? That would be very unlucky. That's only 8%. You'd be very unlucky to only get 1 or no reds at all. To get 2 reds, 0, 1 or 2 reds, 26%, still quite unlucky. The chance of someone getting 0 to 3 reds, that's about a 50-50 chance. That's sort of like unremarkable. The chance of getting 4 reds, up to 4 reds, that's quite unlikely. So then you can flip it the other way. The chance of getting up to 4 reds is about 72%. Therefore, the chance of getting 5 reds or more is about 28%. And if you scroll down, up to and including 5 reds is 88%. It's about a 12% chance of getting 6 or more. However, getting 6 or fewer reds, that's very, very likely indeed. That's about 96% likely that someone that spins gets 6 or fewer. Therefore, flipping it the other way, that means there's a 4% chance the case of this question, i.e. less than 5% chance of getting 7 or greater. And so by doing it as a list, with practice you can get more confident and see what's happening more visually. So if this way for part C has thrown you a bit or confused you, you might want to experiment with the questions in the suggested exercises using the list function. It is quite powerful. On that note, I'm going to leave you now to practice and experiment with these yourselves. So if you were to turn now to 93, exercise 6C, try questions 3 and 4, then 7, 8, 9 and 10. You know the drill by now. Keep working hard, check your answers after every single question. If you've made a mistake, try and spot where you've gone wrong. If you're not sure where you've gone wrong, you can ask one of your classmates. If they're not up to much use, if they're struggling as well, then you can ask me, either on the channel, on email, or in person. Keep working away. Thanks again for listening, and I'll see you again next time. Bye for now.